Today we're going to be looking at the inquiry labs on calorimetry and heat. So for each of the following labs, we're going to outline a brief procedure and sketch the lab. Here's a big hint for the labs. A big hint is this. Whenever you want to find the heat involved in a process that releases heat, what you're going to want to do is have the process release heat to a known amount of water. And you can easily measure the change in temperature of the water with Q equals mc delta T, where you could find the Q, which is the heat. The same can be said for a process that absorbs heat from water. So if it absorbs heat from water, then you're going to be able to figure out the heat lost is the total heat gained. The lost from the substance is gained by the water. Lost from the water is gained by the substance. So let's consider a heating curve for each substance when we do these labs. The first lab is going to be the heat of fusion of ice. So you want to figure out a heating curve for ice and a heating curve for water. So the heating curve for ice, it's going to be melting. So here's the ice, and you're going to have a heating curve for ice. It looks like this. And ice melting is going to be from this portion to this portion. Okay, let's talk about the water. You're going to have some water. You're going to use this water to figure out how much heat was absorbed by the ice. So if you start with some hot water and then cool it down to a temperature close to 0, then you're going to have this part of the graph, which is going to be an mc delta T. So mc delta T, back to this, mc delta T of the water is going to be there. This is the hot water. So now you're going to be melting the ice, and then melting the ice is going to be on this part, and that's going to be an mc. Now the only thing you have to be careful of is the ice, once it melts, it's going to heat up a little bit, and that part, that small part of the graph, is mc delta T. So you could see what's going to happen here. If you have the ice melting, the ice, first it's going to melt, so you're going to have an mc for that. Then the ice is going to heat up a little bit, and that's going to be an mc delta T. Then the water, the hot water, is going to cool off, so that's going to be equal to an mc delta T. And the whole point of this lab is to find out the heat of fusion of ice, which is this value. This is the one you don't know. But you're going to know everything else. And the interesting thing is that this final temperature of the ice is going to be the same final temperature as the water. So those two final temperatures are the same. So the procedure is quite simple. You're going to have a coffee cup calorimeter. Inside that coffee cup calorimeter, you're going to put some hot water, and you're going to have to measure the volume of that water. Now, even though we need mass of water, it's easy because the mass and the volume of water are the same thing because density of water is 1. So you put your hot water into here, and you know your mass, which is really your volume as well. You measure the initial temperature of the water, which is going to be this point right here. This point right here is your original temperature of the water. And then you're going to put a bunch of ice cubes into it. And when you put the ice cube into it, of course the ice cube is going to melt. Now these ice cubes should have been already taken out of the freezer so that they're at this starting temperature of 0. They're not going to be down here because that would be straight from your freezer. So the way to know that is the ice cube would have already started to melt a little bit. So your ice cube should already be a little bit starting to melt, and then you're going to know that you could put that into here. You're going to keep adding ice cubes and stirring with your temperature probe until the temperature of the water goes down to over here, roughly 5 degrees Celsius or so. So I'll write that in briefly, around 5 degrees Celsius. Once that happens, you got to pick out all the ice cubes real quickly. And once you pick out all the ice cubes, you're going to read the final temperature, and that's going to tell you, again, this final temperature right here, which is the same as the final temperature right over here. Now the last thing you have to do is you have to figure out, well, how much of my ice melted? How much ice melted, because you never measured that, but that's easy because you already know how much water you had to begin with right here on the right. So if you measure the total volume and subtract, you'll know the mass of the ice that melted, which is the same for these, and then you could easily solve for the missing heat of fusion of ice. In this lab, we're going to be looking for the specific heat of a metal. The specific heat of the metal is C in the solid state of the heating curve. So remember in the past video I told you that you want to consider a heating curve for each substance in these calorimetry labs. So a metal has one of these drawings, and water has its own drawing. And so what you want to do is you want to find out how much heat it takes to heat up or cool down a metal per gram degree Celsius. So what you're going to do is you're going to take a hot metal and you're going to heat it up in a hot water bath. That's how you're going to know the temperature of this metal. And the whole point of this lab is to do the following. Calculation-wise, you're going to say the mass times C times delta T of the metal, because you're in zone 1 for the metal, is going to equal zone 3 for the water, because it's in the liquid state, the MC delta T of water. Okay, and the whole point of this lab is to find this. So you're going to have a known amount of metal that's going to be in this test tube. You're going to put it into a hot water bath, and the hot water bath has to completely submerge the metal, and you're going to take the temperature of this bath, so you're going to know the starting temperature of the metal. So actually, let me see if I could erase this and do this a little better. Let's see if it'll let me do this. So the metal's going to start off very hot. Sorry about that. So the metal's going to that you know that it really got to that temperature once the water's boiling. Then you're going to take that metal and you're going to dump it with some gloves into here. I'll probably help you with that. And then you're going to keep stirring this until you get a final temperature. So of course the metal is going to cool off and the water is going to heat up. So I'm going to draw it this way. Okay, so the water started here and ended on the higher temperature. So in black, this final temperature right here, TF, is the same final temperature as this cooler temperature of the metal. And now you're going to know your delta T of the water by the difference right here, delta T of water. You're going to know the difference in the temperature of the metal, delta T of the metal. So you'll know this. And then, of course, you know the mass of the metal from the beginning of the lab. And then you're going to solve for the specific heat of the metal.